If you're watching this video right now, then you're probably in your own home, just like me. Now, what does home mean to you? For me, it's a place where I can be myself. Wear sweatpants, do wacky kicks, make weird faces. For most people, home is a place of belonging, and I know that I'm lucky enough to have one and call it my own. Because that's not the case for 70% of the world's population. 70% of the world still lacks access to proper land titling. If you've ever witnessed the process of buying a home, you'll know that it's extremely, extremely convoluted. But at the end of the day, you at least know that that home is yours. For many people in third world countries, nothing is stopping someone from coming in and saying, "Yo, this house is mine now." And just like that, you'd be left without a home. Because without proper land registry systems to prove and secure ownership of a property, your claims mean nothing. The crazy thing is, this actually happened in Honduras. Government officials hacked into the country's database, placing properties under their own name. Another case was in Haiti after the 2010 earthquake. Government buildings containing 60 years of records, including physical land registrations, were destroyed. Without official records of prior ownership, people had no proof that the land was theirs. And to this day, they are still fighting over these lands. One way we can solve this is through blockchain technology. Blockchain is an immutable digital ledger that allows data to be shared and stored globally across thousands of computers. By immutable, we mean that the data stored on the blockchain cannot be changed or altered. And if someone were to try and do so, it would invalidate all the data added afterwards, and so everyone in the network would immediately take notice of this. The only way to make edits would be to add the new piece of information on top of the old one, keeping a complete history of all data. When used with land registration, this allows blockchain to be a permanent, traceable, and undisputable record of property ownership. Blockchain is also decentralized, meaning rather than being one central authority governing the entire network, each computer in the network stores its own copy of the information, and they all work together to maintain its security. This means that there is no single point of failure, making it much more difficult to accidentally lose information or have it tampered with. I built a decentralized land registry application on Ethereum, where you can view, add, or transfer properties. The back end of it is controlled by a smart contract, which is a self-executing computer program that runs on the blockchain, following the terms of the agreement that are coded into it. To perform certain actions, we'll have to pay gas, which are essentially fees in Ethereum. This includes deploying the contract, registering properties, and transferring properties. No fees will have to be paid for simply viewing the lands, however. The front end was created with HTML, CSS, and JavaScript, and was connected to the smart contract through the contract address and ABI. Now let's go over the smart contract code. To begin, we'll have to specify the compiler version and create the contract. We then create our land struct, where we define the attributes that each listed land will contain, including the owner, location, cost, and an ID. Next, we create the constructor, a function that is executed only once upon the creation of the contract. We also define our state variables and initialize them inside our constructor. We create two different event types, one to register land and one to transfer ownership of the land. Next, we have a function modifier, which is used to modify the behavior of a function in Solidity. This is typically used to set a prerequisite to a function. In our case, we want to make sure that only the contract owner is allowed to perform certain functions. We then create a mapping of each address to an array of land structs, since one account can own multiple different properties. Our first function is to register a land. Using the function modifier, we check to make sure that the person trying to do so is actually the contract owner. We then increase the total lands counter by 1 to account for this land, and then create the land object using the parameters passed through the function. Finally, we add this land to the array of lands that is mapped to the address of the contract owner, and notify the network of this by calling the event that we created earlier. Our second function is to transfer land. Before that can take place, however, we need to ensure that the person is actually the owner of the land that they're trying to sell. If all is well, we can proceed with creating a copy of the land object, keeping the same information for all attributes except for the address, since we swapped that out with the buyer's address. We then add this new land object to the buyer's collection and remove it from the owner's collection. We then have a function to display the attributes of a property. And lastly, we have a function to display the total number of lands owned by an account. And now, onto a quick demo.
We begin by compiling our smart contract on the Remix IDE, selecting the injected Web3 environment, and making sure our MetaMask is connected correctly. We then deploy our contract, pay our gas, and wait. Once the contract is deployed, we copy over the contract address into the configuration JavaScript file, as well as the ABI if you haven't done so already. Now we deploy our front end from the terminal. Let's try registering a land, making sure that the current account as indicated at the top is the one we deployed the contract with. We pay our gas, then wait. To refresh the land listings, we click the button up here. Now let's try transferring a land to a different account. Copy the buyer's address and select the land you wish to transfer, making sure you're doing all of this in the seller's account. Again, we pay our gas, then wait. If we refresh, we'll see that the land we owned has now been removed from our account. If we go into the buyer's account and check, we'll see that ownership has been successfully transferred.
Despite everything that blockchain is good for, there will still be some challenges along the way. Governments may reject a system that reduces their own power, and blockchain can't fix land that's already been lost. But we can still remain hopeful. In some countries, government and nonprofit organizations are already starting to make this a reality. By helping to secure property rights through blockchain, we redistribute power back to the owners, taking us one step closer to equitable and resilient communities.